we're going to jump right in now to two applications that are written using VRUI. So VRUI, again, it's the lower level library, and it provides some of the things and then some of the underpinnings for doing virtual reality. And again, you'll see that it has a lot of look and feel that's the same as the demo one we just saw. So this half hour or so, we're going to talk about Toirt, which is Gaelic for volume visualizer. And so that is what we're going to be looking at. And it was written by, as one of the slides say, Patrick OLeary. So I think you can get the connection there. All right, so there he is, Patrick OLeary. So he started writing this in 2007 when he and I were both at the Desert Research Institute in Reno. And, okay, we already said that. And we were working with, some specific domain scientists at the Desert Research Institute who had these volumes of data. And it's, it's not necessarily an unusual story. So Dr. Murray had, slices of, these tunicate fish, and they wanted to count cells, certain cells that were dyed. And so you have these thin slices, you scan each one, and now you've got a grad student or a postdoc sits there and they have to figure out, well, this cell, is that different than the slice below it? And they have to count how many of these cells there are. And so, of course, this at least should be done in a computer rather than counting things on a slide. And then if you assemble them into a volume, like I say, you should at least be doing it on the desktop. But then if there's a little bit of fuzziness involved, a lot of times it's easier if you can actually look around it, see it in 3 space, and manipulate how you color it, how you shade it, and get some good contrast in there. And then also Dr. Lancaster, who does ground penetrating radar of sand dunes in order to kind of see how they evolve over the centuries, and how, and really what they're looking for is how the wind patterns existed in, times past, how the different prevalent winds will cause different patterns in the sand dunes, and so they can kind of use this to go back in time and see how the wind patterns have changed through the centuries. So these were kind of two of the people we were working with. And so again, here's like one slice of this tunicate cells, and they're labeled with fluorescent dyes. And again, grad students or whoever would be counting these things. It would take them a few days to count, one sort of set of slides. And they just want to be able to tag these things and make counts of the different types of cells they see. Oop. All right. I think I'm losing battery on this thing. I should have charged it between... There we go. All right. So one of the things that inspired us to work on this project is a really old VR application, one of those ones that was special purpose built for VR, written in 1994, 1995, and written in part by Dave's old boss, Rachel Brady, at the National Center for Supercomputing Applications. And this is kind of a classic sort of cave application, especially this one over here. Let me move this table out of the way. So this is one I kind of alluded to earlier, where they're trying to track these fibers through this scanned volume, and it doesn't show necessarily here, but a lot of times you get these fibers, they cross, and if they cross at steep angles, computers can't really decide which way it goes, and so you really want to have a human in there. And they would try to do this on the desktop, but with a 2D device it was just very difficult. So the scientist actually, who was from the University of Chicago, which is 2 hours north of NCSA, would come down, like once a month just to do a new data set. That's how he sort of found the value in the cave. Now, we might have thought of porting this, or of keeping it alive. It was, of course, 12 years later, and also it was written in IrisGL, which it's a little hard to port from. It can be done, but it's not something that you necessarily want to do. And this used a lot of use of texture maps. The texture map stuff changed a lot between IrisGL and OpenGL. So really, that plus the fact that here's the opacity map editor, and it literally says good luck to you when you activate it, and it means it. So it really there was some work that needed to be done there, that we needed a better user interface. So writing a new application was fine. We had already had some of Oliver Krylos's VRUI applications running, or at least one, the 3D visualizer, running in our cave, so we were familiar with that. We saw the widgets. Oliver was only a 2-hour drive from us, and so we decided to use, I'm getting ahead of myself. We decided to use VRUI. But our other inspiration then was this better techniques of doing volume visualization. So this isn't necessarily a VR topic, but we're kind of inspired by some of the work done at the University of Utah, where they did more interesting transfer functions, which you see at the bottom there, which kind of go over space. They look at not just the values at the volume, but also the curvatures, the gradients inside the volume. And so we kind of took that as our inspiration, where you can now kind of see things a little bit better. You can find different things inside your data. And so we brought those things together. All right, so our original project was with Dr. Murray and her tunicate slices, and we wanted to allow her and her students a way to explore, to interact with the data, and to eventually count the different cells and different sizes of cells. And then later we added this project with Dr. Lancaster, where we did the sand dunes, and we added a few new features where there was surface warping and a Brunton compass, so you can figure out the angle, and also save and restore. We didn't have save and restore in the original one, which makes it less of a desirable tool, right? All right, so I already talked about, we chose Vrui. It was one of the two libraries that we had at DRI, the other one being one that I wrote. And again, we had some good examples. It had the widgets. Patrick happened to like the C++ method of using app as a class, but especially we didn't want to have to rewrite the widgets, and so we got that free with Vrui. Now Vrui, we had already this 3D volume visualizer tool, and I'll show you that on Wednesday, but the problem was, and it had a method then of doing, in addition to other features, it had a method of doing volume rendering, but again, the user interface for doing the color mapping, the opacities, not as clunky necessarily as crumbs, but still pretty clunky. And we had some new ideas that we wanted to implement, and so that's required a new application. So Patrick did kind of the work on the volume rendering, but here's kind of a basic overview of it. So of course, if we're doing it in the cave, we talked earlier, we need real time. And so one way is to reduce data. The other way, though, is to reduce the data that you're not going to see anyway. And so that's really the better way. So Patrick implemented re-implemented other people's techniques for doing both bricking, which is kind of a first order subdivision of the space, and then doing an octree where you kind of do this adaptive mesh refinement as where the data is located. And so you can cover a bigger volume with a lot less computer memory. This is Patrick's work, where he tried a lot of different ways of how you decide when to stop going down and making smaller and smaller octrees. And so the greedy one algorithm, which I cannot explain, is what he found he has a little paper that he did on that. And then, so the other technique that we used is it's kind of texture maps that always face you, right? So they're view-aligned texture maps calculated in the GPU. You know, one of the kind of generic issues we deal with when we're doing SciViz is, you know, how are we going to color our data? A lot of times people kind of just go with this default. I'll start with red, I'll work my way through the oranges and yellows and greens and blues and purple, the rainbow, and you know, that's easy, but it's not necessarily a good choice for highlighting your data, and it'll show things maybe that appear to be in your data that are just kind of an anomaly of this the fact that there's these kind of perceptual discontinuities in the rainbow, but not necessarily real discontinuities in your data. And so the other thing is we wanted to be able to kind of have a selection of good, we have the bad, but we also have a selection of decent color maps that we can start with, and then you can modify those to highlight certain things, and we'll do that in a little bit. All right, so we're going to run the application. We'll show a few things. I'll get my stereo glasses. You can don your glasses now. And there's the wind. All right, so this is how Toirt comes up when it starts. Make sure tracking is going, there we go. And it comes up with an empty box and shows you the volume. And the reason we come up with an empty box is sometimes your data is really big and the system just would come up very slow. And so we want to give you the opportunity. So now I've pre-mapped buttons, so I don't have to go and map navigation. I do have to wake up the wand, though. There we go. All right, I don't have to map navigation things anymore. It's already pre-mapped, and I do have to remember, but I don't have to map which button does what. Right. So the top thing is to show the volume, but before you show the volume, sometimes you want to downsample or turn on this interactive thing which kind of does an automated downsampling. This volume we don't need to do that, so we'll turn the volume on. It does come up, however, with our bad, crude color map. And so you can kind of see what we got there. But for this data set and for other sort of medical data sets, I like to set what we call the inverse Da Vinci color map. And this is a mist. A little more difficult to do when you're not wearing the track glasses. But I missed again. So this is where if you have the ability to store your choices and just bring it back up. All right, so that's inverse Da Vinci. Again, though, we've kind of got this generic color map ramp. I wanted to show just so this menu. So here, it's kind of like, lots of different features. We're only going to use a handful of these on a typical basis, but you can just, however your application is, you just kind of add them on. And so one of the downsides, if you have too many things you want to do, of course, it ends up getting a little big. And then if you happen to bring it up close to you, then it's a little harder to see the whole list. And yes, I should bring this with me. So have you seen those three things? All right. So I kind of alluded to this a little bit with crumbs. Traditional transfer function editors, especially the crumbs one, but even the 3D visualizer that Oliver wrote, have this kind of clunky things. You often you're individually manipulating points. Let me bring up the Colormap Editor, or the transfer function Colormap Editor. Yeah. Oops. All right. So this olive stuff, this is our histogram of the data, and in this case it's density. And so this line here represents opacity. So we're starting with anything that's very dense is totally transparent, and everything that is very undense is transparent, and the things on the dense side, as you get more and more dense, we make it more and more opaque, which is kind of a natural mapping. And then here's our inverse Da Vinci color map, and again, it's got a bunch of set points, but it's a smooth transition from white to dark through the brown hue, and we can grab each of these points, and I'll do that in a moment. But anyway, this is this is standard, but it's not necessarily showing us really a lot about our data yet. We want to manipulate this. But the traditional way, and this is kind of the clunky way, is if I want to change this thing, if I use the right button, I create a new point, all right, and now I can manipulate this. So now I've made everything transparent except for this dense material over here. Let me make this bigger. There we go. So you can see the dense material, and the denser it is, the darker it is. There we go. And so we can kind of manipulate this way. So this is one way to kind of scout through your data, but it's not as efficient as we might want to be. And then also if we want to like highlight, well, what's this little spike here? If we want to just highlight that, lost my tracking, there we go. Now I have to create several little points. So I have to create a new point, and then bring this one down to the bottom. There we go. So now we see this spike is about where the skin is actually. Okay, so now I've seen this, but now what if I want to see over here? Well, now I've got to move all these points over separately, right? And I literally have to click twice. I have to click once to select it, once to move it, which a good human interface designer wouldn't do in the first place. But so this is kind of the way we would scout our data. But we didn't like that. So the sketch mapping is the way that Crumbs would do it. So the Crumbs interface, you would literally kind of draw this line, draw this opacity map, and that's why it's telling you good luck. Because one, you don't have any physical feedback. You're trying to draw in open space and on a 2D plane, and it's just really difficult. And so, you know, again, looking to what the people that Joe Nis did at Utah, we knew that there was better solutions. And so what we did is this Gaussian curve method, which I can turn on here, which now starts with the line is actually at the bottom here, and I can create an individual curve, spread that out a little bit. And now this is one Gauss, so this is one entity in our color map, and I can grab this bar at the bottom and slide that whole thing. And so now I'm sliding that thing with one smooth operation, and I can scout through the data a lot more rapidly. So I can leave one here, say where the skin is.
That's actually the brain, Bill. The skin and the brain.
The skin and the brain? All right. Now we'll get there, we'll get there. All right. And so already we've made these huge gains in just our ability to interface with, there you can see the brain, interface with the data. I went the wrong way. All right. Actually, and so, so let me do what Eric suggested and bring up the shading map. So these things down here, these are all extra dialog boxes I can bring up. And I'll move this one so it's a little more legible. And so typically, these are controls into the GPU shader that we use on the rendering, and it's got this kind of default de facto shader when we start. One of the things we usually do is turn on some lighting in that shading, and then the pre-integration kind of helps improve the contrast. I typically don't use the tone mapping or the tune mapping. Those are there. We can play with that later if you want to come up and play with it. But you can already see that now we can actually get a little bit better sense with the data set here. It's kind of like the mummy looking. Yeah, I know, exactly. But here we go. Here we can get more of the skin layer. All right, so there's more of the skin, and again, you can see the brain like Eric pointed out. But the nice thing now is I can actually add another Gaussian, say over here, and I'll make this one a lot more opaque. So now you can see, the denser material, the teeth and the inner ears overlaid, and again we can just kind of grab these things pretty easily, especially when you're tracking. When your tracking is jittery, it's not as easy. These could be a little bit larger. That's one of the deficits of this, is these little grab points are sometimes difficult to grab. We can kind of scout again through the data with high density. And then if there's something we really want to see, we can just modify a section of the color map and kind of add to the ability to highlight. All right, so we had some discussion before the bootcamp here about one of the things I find even easier is there's some features that I think are difficult to find using these. This is still more or less a traditional traditional transfer function. Patrick also took this idea of the 2.5 transfer function, which is really a gradient versus value. So you highlight features that are specific to where there's the density is a certain level and it's curving at a certain thing, right? And so let me bring that up. And so that one I think lets you find some features a little more easily, although whether it's impossible to do the others, not for me to say. So now I can only bring up one of these at a time. So here's something when I bring up the 2D transfer function, it does a little processing, pre-processing, and it'll take away what we'd already done. And now here it comes with a little tool that shows us our data. Well, let me explain that too. So this grid that comes up, that means you're getting close to the screen, so be careful. So we have these little protectors on. It happens either when the head, well no, I guess the head is turned off. But we can set it so when the head gets close or when the wand gets close, it'll happen to the floor as well. So that's kind of our screen protectors in the virtual reality space. Anyway, so here's a slice of the data, and I can control that slice here. Let me move around so other people can see too. There we go. And then, so this is the actual data on the left. And then it's showing me on the right the gradient versus the value itself. And I asked Patrick, but I don't know yet which axis is which. And so we kind of see there are these little features that kind of highlight. There's certain structures that are kind of common in this style. And what we can do now is add a different kind of transfer function editor. This time they're all going to be the same color. We're going to color like a region of these points. And again, the little tear-off things could be a little easier to grab. There we go. So now whatever's covered in this little triangle is what we're seeing over here. And again, I can move this thing if I grab it. And we can scout through the data. So I can find anything, again, that's under this now polygon, or foregon. is highlighted in red. And we can do multiple ones of these in different colors. So one of the things I found just by scouting is I can find where the eyeballs are a lot more rapidly with this data set, or with this method, than with the other method. And we can shrink that down. I can take this other one. Whoops, I created a point. Don't remove quadrilaterals. Did I get that? All right. So there's a bug. All right, let's go back. So we don't need the color map when we're dealing with the 2.5 transfer function. Doing its pre-processing. All right. So I'm going to stand closer to Harry here to get a better interaction. There we go. Actually, I'm going to bring this closer to me so it's bigger. So it does a little processing every time I interact with it. I don't recall it being that slow before, though. Oh, let me put it in interactive mode. All right, let me put it in interactive mode. There we go. All right, there we go. So interactive mode, again, is doing the kind of the intelligent downsampling, so that things will be a little bit more smooth. Can't see my red line. There we go. All right, so what I wanted to show you is you can have two of these and you can have them at different colors. And so here again, they're solid colors, but they cover different regions of the space. Lost my tracking. There we go. Create a new one. Create a little coverage space. All right, and I'm going to change the color for this one then, be something that contrasts there. And again, we can, oops, missed. So this is where I feel there's still some work that could be done with the user interface. So again, we can scout the data then with this other color. There we go. So there we can kind of see the brain a little bit, and then the eyeballs, I think, really show really well here. Whereas with the 1.5 degree, or with the standard sort of transfer function editor, I think it's harder to find. Although, maybe you can come up and try it yourselves. See if you can find that. Right, okay, so I've kind of talked about everything here except this last thing. One of the things I think we should be able to do is link this transfer function editor with the other one so we can have kind of both, a little bit of each, and put them all together. We just didn't get to that feature. And I think that may be what else we have. All right, so I've already showed that. All right, so we did that. Yeah, so the only thing I didn't show actually is the lighting, which is kind of one of the, oops, move this guy over here. one of the least lower interesting things I'd say on the thing, but let me just do that anyway. I'm going to bring up the 1D transfer function editor. Maybe. So this is where, on the desktop, of course, we have a lot better control of our mouse than we do here. Whoops, with our wands. So that's where kind of the 2D, bringing the 2D in might have been, you know, okay, but bad color. All right. So I'm going to turn the shading back on, which we've already seen, although with a better color map. And then the one last feature I was going to show then is the ability to do lighting. So this, and the reason I want to show this is here it's kind of a 3D widget. So if I rotate this and face it, our ability to actually control the lighting now is actually in 3D. And so this is one of the places where, you know, we still have something that looks like a, oops, I had to grab that thing. Looks like a 2D widget, but actually is now in 3 space. All right. Oops. Got sidetracked. All right. So I already talked about, so here's the 2D transfer function editor. I got a little ahead of myself. Ah, yes. So we also have the ability to render slices in the plane, or in the data set. Oop, I got out of tracking range there. So this is, yeah. Just going to throw those over to the side. All right, so slices is kind of your traditional orthogonal slices in the data. I can turn on the X, Y, or the Z slice. Oops, it's not turned on. There we go. And slide it through the data. So no opacity, it's just full color. And then if I bring back my Gaussian here, I can lower down the opacity of the color map. There we go. So our volume is still there, but just much diminished. So here's this, we can have all these things that are floating in 3 space. So they're 2D things in 3 space. Turn on the Y, slice that one. So that's kind of, again, that's kind of another place where we're bringing in traditional stuff, something that we're used to if we have kind of a desktop scientific visualization tool. So at least it gives us a place to jump off and be familiar. And the one other thing that I want to show is this ability to then add, we do a little 3D locator, and I can now slice the data, you know, again in 3 space. So here I can rotate my wand. I have control over all 6 degrees of freedom. I can move, you know, translate it to affect it, rotate it in any direction, and I can bring it out in space with me, and then turn on the cutting plane. Well, I don't have head tracking on, but normally if I had head tracking, I could also walk around with it and slice at the same time. And get right in there with the data. All right, I think that is all we were going to show with Toirt. I think the batteries are low on this. I should have charged it. Is there a way to advance the slide? I don't know. No, it's not on my laptop. I may be on the last slide. All right, I did that. Oh, where'd my little envelope go? Can you look in the notes? Do the notes have? We should have charged. Do we have special batteries for this? Okay, very good. So let me move this back away because it's annoyingly bad stereo. There we go. All right, so that's kind of the demonstration. Here's one of the command lines to run it. So we run the executable. We have a lot of different things kind of to control the octree. So I have notes on this that, so we can control, how long it takes, how much data we want in a leaf node before we start going to a new level of the octree. For a lot of the data that's raw, we have to tell it, the shape of the data, and then we can affect the scale of it as well. And basically, it'll take several different data formats. A lot of the ones we have are just kind of these raw data packets with binary values. And so this actually runs on the desktop, and Eric was asking earlier, what does it look like when we run on the desktop? And I hadn't planned to show it, but it's a good question. So I'm going to show what it runs on the desktop. But this command actually runs on the desktop, and then what Vrui does is he has what he calls these root sections, which are different configurations, you can think of them as, and then we have one that's AVL, Virtual Reality Theater, and so when I run it in the cave here, we always add that, and it runs in the cave, but if we don't add that, the same application runs in the desktop, and so I'm going to go ahead and do that. And grab this keyboard here. So let me just go to the command line. And I have scripts ready to go. So let's just do the, uh-oh. Problem with on the fly. All right, so here is Vrui on the desktop. So it's not in stereo. We didn't specify stereo for this. So I have now the mouse lets me rotate by default instead of by grabbing with the wand. The right button gives me the standard application menu. You can see now that the menu is screen aligned, and so it's easy to read. It doesn't accidentally come up facing you, orthogonal to you. I can turn on the volume here. Rotating now is a little bit more difficult, especially if you want to get rid of a twist, which I went the wrong way. But of course, it's a lot easier actually to choose the color map you want because the mouse is a lot more precise, and so I'm not going to miss on the color map. And also the 1D transfer function editors, I'm far less likely to miss those little, oops, wrong button. These little tear off things. Much easier to grab those without mistakenly hit something else. So in some degree, if you with the ability to save and restore, which was added later, you could set things up on the desktop, get your kind of common things that you want to do going, and then bring it into the cave and just add things like the cutting plane. So the cutting plane here is now going to be more difficult. Matter of fact, I don't even know how I would control it. But if I switch to the 2.5 degree transfer function editor, put it in interactive mode, oops. Whoop, there I missed actually with the mouse. And we can scout through the data. So for a lot of these things, where we're doing 2D things with the 2D interface, the desktop actually is pretty convenient to use. It's just then when you want to view the data, we can render it in stereo on our desktop if you have a stereo cable display, or just kind of rely on rotating. Right. So
throw it into a spin.
Okay.
Stupid Vrui trick.
Yeah, there we go. Whoops, I want to get rid of that menu though. Let me get rid of the menu first. All right. See, but here, trying to orient it how I want is a little more difficult. Oops, wrong way. All right. All right. So, so Oliver, to a large degree, has managed to make a tool that works pretty well on the desktop and in the cave. At some point, if you're doing things like this that render here, he maybe was too successful, and you might not even think you need to go to the cave. But some of the interactions, especially grabbing it, walking around it, being in the space, doing the cutting planes, those are still sort of cave-like features that you want to be able to do. But certainly things like interfacing with 2D menus is far easier to do with the mouse. And as a matter of fact, Let me bring up the cave version again. We can actually still use the mouse, if I can find it. Oops. No, part of, yeah, I mean, yes, that would be something to consider. Part of our goal was to not have to, am I not working? Oh, repeat the question, yes, sorry. So Chris was asking, whether we considered other styles of menus like radial menus, things like that. And so I guess, we weren't really looking to do more HCI work, right? Or if radial menus were part of VRUI, we would have used them, but part of the reason VRUI was chosen was that it already gave us menus and stuff, and we didn't want to be writing menus. But yes, that would be something worth trying. We just were trying to be, efficiency programmers, right? Which is a longer way of saying lazier programmers, right? We didn't want to. Let me actually bring up a different data set too while we're here. I lost the mouse though. Where'd that mouse go? I don't think so. So this is a bit of an impromptu demo. I haven't. Let's see. I'll set this. Oh, that's going to help. Yeah. So. No, it shouldn't be. All right. Well, we'll demo this later. That was an impromptu thing that I didn't practice. Should have practiced that. So, and so here's another data set. If you want to, some of the things we can do. When we're sort of off. Oops. There we go. So this is a combustion engine. Whoops. For this, I do not know. The data acquisition method for me was Google.
Okay.
Google and go to Utah's data collection website. So here I can't, that looks pretty easy. There we go. And so one of the things, yeah. Oops, I haven't even tried those. So these are more access to different aspects in the shader library, which I don't want to have to go into. If I can get this thing to turn on. There we go. All right. So anyway, we have a few more data sets if you guys want to try these out afterwards, between talks and dinner, or during breaks. It has, yes. And of course that makes it, so we're below 12, so the frame rate's actually showing on the screen, it's below 6. So yes, it makes it a lot more difficult to interact with. All right, so can you advance my slide? I think we're pretty close to the end of the slides here. Yes, so these are the command lines. Basically, how much GPU memory do you want to allocate to different texture sizes, and how many slices are you going to do? The leaf size is how deep do you want to go in the octree before it's considered a leaf node. Scaling and sizing, that's easy, and then reading files. So kind of standard, not too exciting. And I think we're towards the end here. Yeah, go ahead. I guess I should be charging that thing though while we're not using it. Yes. So different data formats. Most of our data sets we get are raw, and sometimes you actually have to figure out the size of them. We have this special NLV, Nick Lancaster volumes. And then a few from different, scientific societies that have decided their own formats. And then some are just, a head. It's basically a header with a number of the X, Y, and Z size, and then bytes, right? Yeah.
So when we've done work with people with medical data, it always comes in as slices.
Right.
So I was wondering what the workflow to go from like a directory of slices
I use JImage. JImage. So Dave asked how people take slices, because medical data often comes in slices, and how you turn that into a volume. So JImage is just a Java image processing tool that downloads and installs pretty easily. Next, please. All right, so enhancements are things that were added to the Nick Lancaster data. So here's a picture that kind of shows that we don't have this data here. This is back at DRI. So again, so we kind of did a space warping. So you saw in the examples here, everything was kind of cubic. Well, the sand dunes, they collect the data by going over the surface, and so you end up with a volume, but the volume is really following a manifold, a surface on top. And so in order to kind of better represent that again, some features were added to rewarp it. And then the Brunton compass is this dialog in the background, which is kind of like the measurement tool we saw in the sample, where you get the slope of the surface and the compass value, the orientation. And I think that's probably it. Oh yeah, so you can download it. So this is a slightly older version. The last stable version was for the previous generation of RUI. But Idaho has recently compiled it for 2.0. Simon has recently compiled it for RUI 2. So if you download from here, you're getting an old version. So right now, and I asked Patrick this the other day, you know, whether he wants to sort of, we consider it open source, but it's not easy to get. It's mostly by, you know, handoff from one person to the other. So we're going to try and find a place to put it that's kept more up to date than that Google Code thing. This was that version there. Yeah. Mac OS X. Yes. Yes, we have the whole broad range of. Oh. I do not know if he's tried Cygwin with this. I have not tried it myself. That's a good thing, though. I do usually put Cygwin on machines when it has that other operating system on it. Oh yeah, there we go. That is definitely the end. All right, so we're going to jump right into the next talk, which is very similar to that talk.